For the last 70 years, our computers have spoken one language, binary. You can think of it like a coin toss that has already landed. Everything is reduced to a simple 1 or 0, heads or tails. This either-or system is incredibly reliable. It's the right tool for running exact calculations, applying strict logic, and solving straightforward math problems. But the real world doesn't always operate in perfect absolutes. Life is full of nuance, messy variables, and situations that aren't easily solved with a simple yes or no. When we try to use a traditional computer to navigate that physical uncertainty, its rigid logic starts to hit a wall. Instead of a coin that's already landed, imagine a scenario that looks more like a coin still spinning in the air. How do you calculate the exact value of that coin right now, while the outcome is completely undecided? A standard computer struggles here. It has to pause its work and wait for the coin to drop so it can read a definitive heads or tails before it can move on to the next step. If you're trying to make complex, split-second decisions based on live data, waiting for that absolute certainty creates a bottleneck in the system. To solve these kinds of problems, we need a way for the computer to work with the spin itself, rather than just the final result. Scientists built quantum computers to do exactly that. They use a concept called superposition, which allows them to calculate those spinning simultaneous states. But there is a massive physical hurdle. Keeping those delicate states stable requires multi-million-dollar laboratories and freezing temperatures colder than deep space. Because of those extreme requirements, you can't put that kind of computing power into a personal device, a laptop, or a local network. The ability to process multiple possibilities at once is a major step forward, but right now it is restricted to those who can afford the massive infrastructure. This is where QxBin comes in. Developed by pikk.company, it's a software framework designed to simulate that same quantum intuition on standard room temperature hardware. Instead of rigid ones and zeros, QxBin uses a binary probability matrix, assigning fractional scores to outcomes. It recognizes a result is 70% likely heads, 30% tails. With these shades of probability, the computer evolves multiple possibilities simultaneously, just like the spinning coin. The breakthrough here is that all of this probabilistic calculation is happening entirely on an everyday, off-the-shelf laptop. QxBin is a change in the way software is built, making it possible for standard computers to handle these complex possibilities without the need for a cryogenic laboratory. Let's see how this works in the physical world. Specifically at the edge, the point where computers meet live data, like the hardware in our streets and shops. Take a smart EV charging station. Throughout the day, the power demand from different vehicles changes constantly, making it highly unpredictable. Instead of reacting to one vehicle at a time, the probability matrix allows the station to predict and balance those energy loads simultaneously. Until recently, this level of real-time optimization was thought to require a supercomputer or dedicated quantum hardware. QxBin makes this kind of complex balancing act practical, running it directly on the small, decentralized devices we use every day. We no longer have to wait decades for expensive quantum hardware to become a household item. The mission of the QxBin framework is to take these advanced tools out of the high-end labs and put them into the hands of anyone with a curiosity to experiment. It's about finally being able to work with the power of the spin, even before the coin lands. QxBin brings the power of the spinning coin directly to the computer on your desk. No cryogenics required. To start building, visit pikk.company.